Hello everyone, I am Shuvardhopal and today we are going to design Microstrip Patch Antenna using HFSS. So here are the dimensions and the layout of the patch antenna that we'll be using. Not exactly this one, but very similar to the design shown over here. We will be using coaxial feed for the antenna. Let's jump to the HFSS part now. Okay, so now we are in the HFSS part, and what we need to do is create a new file, create a new project first of all. Then for this we need to go to file and click on new. A new project will be created and we need to give this project a name by saving the file with a particular name. So we'll be saving the file. So we are going to save the file, and after saving, the name will come over here and we will choose this option, which is insert HFSS design. Upon selecting a new Cartesian system, 3D Cartesian system will appear on the screen, and here is the place where you need to design the blocks. So we can start designing the antenna accordingly. The first thing we need to do is add a ground plane in the antenna. As you can see from the dimension part, that we need to add a ground plane first of all in the base first. So for adding the dimension, we are going to choose the box, because we need to draw the ground plane, as I said. This is the arbitrary box for arbitrary values. We need to send the design so that we can work on this. Let me adjust the plane accordingly. So this is the correct position. And then we need to give these values, the values of the box dimension. The box, this is known as the ground plane. And the material would be of copper. You can search the material over here. This is the copper, and we're going to choose this. After selection, this is the thing, and you can set the transmit to be of 0.8 so that the structure becomes visible. After selecting OK, the box, this is the copper one, and I need to rename this as a ground plane. This is not taking the name because of some reason, maybe. Ground plane. Also, right now it can take the name without spaces. So after giving it the name, we can set the dimensions. We are going to set the starting position to be of 0 0 0. The x size and y size are the length and the width of the ground plane. So one second, let me check from if there is any dimensions given in the slide. There is no dimensions of the ground plane given in the slide, so we are going to choose the arbitrary values. So I am going to choose the x side to be of 40 millimeter, giving this a you can use some variables so that we can use these values later on in the design. Length ground, so we're going to give this value of 40 millimeter length. X size, again, this all these things are okay. So I says this should be the length, width, ground, we are going to give this dimension to be 30 millimeter. You can choose accordingly to your need. The XZ side is actually the height of the box, and which is supposed to be the thickness. So if you check in the slide, there is a thickness of 0.2 mm, so we're going to use that. 1 second, use something wrong, I suppose. Yes, so we're going to choose this is as the height of this thickness. So I'm going to click upon thick ground, give this thing a variable name, and we're going to give this value as 0.2 millimeter. So upon setting all these things, the position should be 0 0 0. We can click on OK, and now you can see the thing has been created. Bring the whole structure into the view. As you can see, the ground plane has been created. Now what we need to do is add the substrate layer. The substrate layer is also a box of different material, maybe. So let's see how can we do that. So for adding the box, what we can do is just copy this thing first and paste it over here. Okay, so this thing is should be the substrate layer. Okay, substrate okay, substrate layer. The material should be of I think it should be of some other material. I'm going to choose of Dielectric 2.2 as given in the question, I suppose. Yes, there is a Dielectric of 2.2. So what we need to do is come over here, 2.2. This is the thing that is Dielectric 2.2. If this is not present over to your case, then what you need to do is you can create your own material by clicking on this material, adding material. Yes, add material. You can create the new material and give the values according to your need. So I have this Dielectric 2.2 of relative permittivity. I'm going to choose this value. So this thing has been chosen, and I'm going to choose 0. Okay, 0.8 sounds good to me. So let's keep this thing over here, and what we need to do is change the position dimensions if required. The length and the dimensions should be the same. The height should be of the height of the substrate, which is is given, yes, 0.7874 millimeter. 0.7874. Okay, so this is going to be named as thick of substrate, and getting this is going to be of 0.7874, right? Yes, 0.047 millimeter. Don't forget the unit in this case. Okay, and the position, the x and y position should be the same, but the z position should, the substrate needs to be raised above the ground plane. So the z position should be thick ground. Now as you can see, I'm going to show you. Okay, just wait a minute. Yes, this is the ground plane structure, and this is the substrate layer, as you can see. So this part has been completed. Let's check what's left. After this, we need to add the patch, which is the primary component of this antenna. The patch is also the box of copper, we can say so. So what we're going to do is we are going to copy this thing and paste it over here and give this thing a name. 1 second. Okay. So we are going to give this thing name as patch. So after creating the patch, what we need to do is adjust its dimensions and position accordingly. So the materials are same, and on the sensor together we need to change the dimensions. The length should be of length patch. This is patch, which is given in the slide to be about 16 millimeter, and the width ground should be changed by width patch, which is given in the question to be 9 millimeter. The thickness should be same as the thickness of the ground plane, and you can click on OK. And as you can see, the thing has been created and it's in the lower left corner. So we need to shift this thing towards the middle. So further, what we're going to do is use some other parameters to set its position. So in the position part, what we need to do is okay, yes, the length of ground minus length of patch by 2, and we're going to do this thing for y-axis also. So with width ground minus width patch by 2, and the z should be at above thick ground plus thick substrate. So we can now click on OK. As you can see, the whole patch has been shifted towards the center, and if I show you from a different angle, you can see the thing has been shifted towards the center as we were desired. So this part has been completed, and the next part that we need to do is adding the coaxial. Okay, so for adding the coaxial, what we need to do is add a coaxial port from the below part of it. So for that, what we're going to come to the design section and uh, create a cylinder of copper. So let me adjust this cartesian once more. Yes, so a cylinder should be made. Cylinder should be made using, yes, the cylinder has been made. You can see the dimensions and positions are not yet decided. So first we're going to decide that. Let this say as a coax is coax inner 1. So I'm going to name this coax inner 1, and material to be of copper, and other things should be kept as like this. So once you can change the dimensions accordingly. So the radius I think should be around what should be the radius? 2.5 millimeters sounds good to me. So I'm going to name this thing as coax inner 1 rad 1. Coax inner rad 1, and I'm going to give this value of 2.5 millimeter. So click accordingly. The height should be named as a parameter also, and should be named as coax height. So coax height should be given value of around I guess 2 millimeter will work. This thing, let's check. This thing is we have correct dimensions, and now we need to change the position so that it's in the desired location. So for that, what we need to do is the x-axis, right? The x-axis to be around what we need to do to be in the center of the x-axis, right? Let me check. Okay, so this thing should be in the center part of the x-axis. Show you very yes, this cylinder should be in the center of this x-axis in the structure. And so for that, what we need to do is we need to change the position. So yes, x-axis position should be changed. So x-axis position is uh, length ground by 2. Just as you can see, the position has been changed to the middle of the x-axis. Now we need to shift the y-axis. So similarly, we can also set the y-axis to be around width of ground by 2. Yes, you can see the cylinder has been shifted towards the center of the structure, and if I show you from different angle, the whole thing is in the center of the whole structure, the cylinder. So we need to shift this cylinder to the bottom of this ground plane so that it can connect to it. So we need to change the z-axis. The z-axis should be not, I think not 0 mm. What you need to do is, let me check once again. Yes, I need to do yes, a minus of coax height. Coax height. As you can see, the structure have been moved towards the bottom, and it's in perfect contact with the ground plane. Yes. So now what we need to do is we need to create a coaxial part. So for that we need to have a hollow cylinder, not the solid cylinder. But before doing that, we need to copy this cylinder, because we also need to cut the ground plane with this. Control C, Control V. So this is the, so I'm going to name this thing to be a coax cut, so with the ground cut, ground cut. And after that, what we need to do is change the height, I think. Yes, just wait a second. The coax height should be plus thick ground. Yes. So now, as you can see, when we are clicking this and the ground plane, we can now subtract the both, so that we can get a hole in the ground plane. And for subtracting the object, both the materials need to be of same materials. So I selected both these structures and click on subtract over here and click on OK. Now you can see, let me show you the triangle. Yes, there is a hole in this structure, what we desired, because from this part also, only the coaxial probe part will enter to the patch part, and so we need to have a hole in the ground plane. You can see there is a hole. So for now, what we need to do is next, is we have the coax inner one, and we need to have a coax inner 2, because we need to subtract both of them to get a hollow cylinder and not the solid cylinder, because in case of coaxial, as you know, the transmission line or the feed part needs to be hollow. So I'm going to copy this thing and paste it over here and give this thing a name of, the name is correct, what I am supposed to be naming, and the dimension should be changed. uh, Then a new dimension would be just coax inner tag 2, and so I'm going to name this thing as a 2.0125 millimeter. This is the assumed value, and you can change according to your need. I'm going to use this value. The other part should be the same, I guess. So now if I show you, this is the inner one and this is the inner two. We need to subtract both of them to get what we need. Just a second. Before cutting this, what we need to do is we need to copy this thing and paste it over here, and we will use this thing later on in the design part. So what we need to do is, for right now, is select both of this and subtract. After subtracting, you can see the cylinder is has become hollow now, and the cylinder is hollow, and what we need, what we have desired, is have been achieved. So the cylinder needs to be hollow, as I said, because of the coaxial feed. And the coaxial part, there is a ground conductor, and there is also a probe part, which will need to be contacted with the patch part, because the signals, the electromagnetic field would be traveled through this. So we need to have a probe, and for that, what we need to do is use this third cylinder that I have used. So this is the coax inner one, and this is the coax inner 3. So this is coax inner 3, and what we need to do is change the radius and other parameters accordingly. So this time the radius will be at 3, and the inner radius of the probe should be about 0.6325 millimeter, and this time the height would be different, little bit different. So the height would be coax plus the height of the ground, thick of ground plus thickness of substrate. So if I click OK now, as you can see, let me just bring this transparency to be of 0.9, so you can see the structure very well. Yes, now you can see the new cylinder that we created right now is a little bit longer than the previous ones, and it is touching uh, the patch part. If you see very closely in this structure, yes, it is touching the patch part perfectly, and it is coming from the coaxial part also. This inner conductor is the probe part, and before continuing, what we need to do is create a copy of this thing also and paste it over here. And this coax inner part for the material needs to be changed. The material that we need to change is this duroid TM of dielectric permittivity of 2.2. So we click OK, and why we did this is because we need to create a hole in the substrate part also before entering the probe. So for creating the hole, we need to have the both the materials of the same, both the structures of same material. So we copied the structure of the probe and copied and change the material to be of substrate, and we can now select both of them so that we can now subtract them and click OK. As you can see, the hole have been created in the substrate part, and from that hole the probe will enter. As you can see, the probe is this one, and the probe have entered to the patch area. It is in contact with the patch, and we don't need to do anything as of now. And the one thing that we need to do is just over here. Yes, as you can see, the outer conductor is this one and inner conductor is this one, and there needs to be a something in between as dielectric. For coaxial, what we have as dielectric is a permittivity of 1.9 is generally used, and we are going to also use that. And so for that, what we need to do is we have already subtracted this cylinder, I guess, so we can copy that. We have subtracted this, so we can copy this part and paste it over here. Okay, so this thing is coax inner 5, let it be. The material needs to be to have that value, right? So it should be of material 1.9 dielectric. Yeah, if I don't have, I have to create this, but I most probably have that. Let me check. Okay, I guess I don't have that value, so let me DC one. No, I don't have that value, so I'm going to add the material, and what we need to do is relative permittivity, change the value to be of 1.9 and name the value material to be DC1P9. Yes, DC1P9. click OK, and then and all the rest of the things are okay. And so this is the inner dielectric of the coaxial part. But the one thing that we need to keep in mind is that there is also a probe entering through this, so the dielectric cannot take the whole place. So what we need to do is copy this inner code and paste it, and change the material to be of DC1P9, DC1P9, and by using that we can subtract the value. As you can see, both the things are same material, and I'm going to select both of this and click on subtract. So after subtracting, yes, as you can see, the dielectric has been hollowed, and the inner part consists of the inner probe, and the outer is the outer probe. So I'm going to name this thing to be a copper inner coax probe. Because this represents the probe of the coaxial cable, and this inner one needs to be a outer coax outer and coax probe. So both functions have been renamed accordingly. So what we can do now is we can validate the design a little bit. Okay, so as you can see, the materials have been designed accordingly, but one thing that we need to keep in mind is that the feeding part is in the center of the whole design, but in real life it doesn't happen. The position of this thing actually varies with the it is decided by the designer up to what distance it is kept from the center. So what we're going to do is add an offset to the value, the position, so that it can be a little bit far distance from the center. So for that, what we need to do is what we have is this patch, okay, ground probe, this one and this one, okay, this one. So we need to change the values of these positions. So I'm going to add an offset to these values. So the X position, right? Okay, the Y position needs to be changed, and for Y position what we can do is minus, okay, so minus fy is the offset, and minus offset y, minus offset, and offset y is a value, and we are going to choose that value to be of around 3 millimeter. Let me check what I did. Yes, this part has been done correctly, but we need to change the values of every other part that is coming in this respect. So we are going to use offset y. We're going to subtract the values of the y index from that. So we need to shift the whole object of coaxial accordingly. This case also is going to subtract the value offset y. This thing has been shifted, so the ground plane is the same, the patch is same. Let me check if this needs to be changed. the ground. Okay, this needs to be changed, I think. So offset y. So we are basically shifting the whole of every position of the every aspect that is related to the coaxial part, and we need to do this because so that there is no overlapping of the regions, and this can lead to conflict while solving in the HFSS part. This is the inner core, and we need to change the value for this as well. This is one time process. Once you do it, you don't need to do it anytime other than this. We need to do this from the starting, but we haven't done this because I forgot to do that. But you can do this thing later also. As you can see, the thing has been shifted, and we need to change the position of everything to it. Okay, so the whole thing has been shifted. Okay, so what we left is this layer, I think, because this also consisted of the inner part. So offset minus offset y. So now you can see the whole structure has been shifted according to our need. And let me show you one thing. Okay, right, look, wait, this dielectric is 0.9. It needs to be a transparent so that you can see the whole structure, and the pro part needs to be a transparent, because you will not be able to visualize the structure there. Yes, now as you can see, the design part is almost complete, and you can basically work upon on this according to your need. As you can see, the proof part have been shifted to with an offset, and this is one time process. You don't need to do it anytime more. And if you want to change any of the parameters, what you can do is go to design properties, and here are all the variables that we have used in this project. We can change any of the values and change the whole design basically. So I'm not going to change over here, but you can change the values and fit this thing according to your need. These are the variables that I've used in the whole project, and this thing is almost ready for the final part. Before solving, I'm not going to solve in this video, but this video is only about designing part. And let me check if there are any error. As you can see, there are two error: boundary and excitation. So what we need to do is set a boundary. For setting up the boundary, what we can do easily is take this ground plane and copy this and name this thing rad box, radiation box, and it needs to be of a vacuum. Okay, so this is the radiation box vacuum. Okay, what we need to do is, as you can see, there is some hollow part over here, and we don't need that. So I delete the subtract part from this, and the whole structure is now solid. And I'm going to change the dimensions of this. The height part needs to be changed. The height should be of thickness of, sorry, height of the radiation. So the height rad box, I'm going to use the parameter for this. So height rad box is 20 millimeter, I'm assuming. So 20 millimeter. So after clicking, as you can see, the radiation box has been created, and radiation box is of type vacuum of material, and this needs to be of transparent. so that you can easily visualize the inner structure. And what we need to do is, after creating the radiation box, we need to assign the structure to be of radiation of the solution of the model. So for that, we're going to click on the structure and assign boundary radiation. So after clicking on this, there is ask for the name and click on OK. So this has been assigned as a radiation boundary. You can check this from here. Boundaries and radiation one. And this pattern shows that this structure has been set as radiation boundary. So after setting that, what we need to do is set up the port for that. So the design is almost complete. We can now just set the port. And for setting up the port, what we need to do is we need to have a sheet. Okay, we need to have a sheet of this thing. For having the sheet, what we can do is create a circle of the exact radius of as the outer shield. As you can see, the sheet has been created as a circular sheet, and the radius should be same as the used in the coaxial part. And for that, you can see is coax outer. Okay, wait. So here is coax outer, and from the coax outer, what we need to do is get the value of this radius. Control C. I'm going to paste this value over here and click on OK. As you can see, this is the exact dimension as the inner dielectric. So what I need to do is copy the position from there and paste the position over here, and you can see the dielectric is wait a minute, yes, this dielectric is the same dimension as this circular sheet, and this it will be assigned as port in the design. Oh, 1 second, this can be deleted if not assigned. So what we can do is 1 second, we delete this. Yes, so we can set this thing as the port by just clicking on this and assign excitation, and this needs to be a wave port. Okay, so wave port, let's click on next. Okay, so you don't need to change anything, and what we need to do is de-embed, and for that what we need to do is de-embed is the subtracting the part of the coaxial feed used in the design from the calculation, so that it doesn't affect the antenna performance because of the transmission line. So we're going to subtract the design distance of the coaxial height coax, I guess. Okay, let me just cancel this thing once and see what is the height of this thing set as. So this has been coax height, not height coax. So going to set this thing again. Assign excitation wave port. Click on next. Next, you don't need to change anything. Just click on de-embed and coax height. Click on finish, and you can see the excitation has been created. And this arrow represents the part which needs to be from where the excitation will start, because we have de-embedded this portion of this offset portion extra, which is taken up by the feed area. and so we don't want the antenna performance to be affected by this feed area. So we have just removed this thing part of the from the calculation. So as you can see, the design part is almost complete and we have nothing more else to do apart from just setting colors and transparency of the materials. So you can see this outer is the outer part, this is the probe part, this is the ground plane, this is the patch part, and so I'm going to color the ground plane. The design part is almost complete and you can save this file like at this present state also, but I am going a bit further and just using some color to show the different objects. Let me verify the design once if there is anything. Analyze setup and the boundaries and excitations. Let me check. No solution has been created. Okay, just wait a second. So as we keep seeing that there is some error, so what we need to do is set the analysis first. So what we need to do is go to analysis section, add solution setup, and we're doing the calculation at 3 gigahertz as of now, and we can change the number of buses to 15 and just click on OK. As you can see, the analysis part have been added, and we can also add a frequency sweep because we may need to view the results according to the frequency variations, and 0 1 to be the step size, and the starting frequency of 1 gigahertz and stop frequency of 5 gigahertz, and the step size will be 0.01. We want the sweep type to be a fast, and just click on OK. And if we check this now, what is this? This part have been completed. Boundary excitation 3D model needs to be solved. So what we need to do is view is what is the problem of this thing. Okay, so I have found the problem. What need to do is this structure is out of the box, radiation box. So we need to put that thing inside the radiation box, and for that we need to shift the starting position x and y and z. So it should be a coax is correct height. Yeah, this will solve the problem, I guess. As you can see, the subject have been shifted toward this. Now if we check the design, as you can see, the all have been shown green. That means the design part is complete. And if you want, if you can see that the coax part was intersecting with the radiation box earlier. Now I have shifted the position of this box a little bit lower side, which is equal to the height of the coaxial feed, and now the coaxial part is also inside the radiation box, so there is no error. So we can, the design is almost complete and you can use this thing in your projects or experiments. And what we are going to do is just add colors and transparency to the object so that it's easy to visualize. The most important parts are almost complete and you can skip these portions also if you need. Okay, so after that what we can do is just color this thing in patch and set the transparency low so that it can be seen. Setting the colors and transparencies helps in the visualization of the objects, so that's why I'm doing this. It's not mandatory for you, as I've said. You can skip this part of the video. So this is our final design, and the design part is complete, and our task is successfully done. Thank you for staying up till the last.